Okay, so hello. I hope every one of you is fine. Okay, so basically the question that we are going to do today is find unique element in an array. Okay, so for example, we have been given a particular array. So let's say that this is my array 1, 1, 2, 3, 2. The thing is see, the question states that there is only one element which is unique. The rest all elements are repeated around 2 times. Okay, okay, I hope you get it. So basically, the thing is you have been given a particular array where only one element is unique and rest all elements are repeated 2 times. Okay, so we need to solve this. Like we need to tell out which is the unique element in this array. I hope everyone gets my point. Okay, so like what can be the intuition behind it? What I can think is if I somehow gets to know the count, like if I somehow gets to know like one appears 2 times, two appears 2 times, and three appears 1 time. If I somehow get to know this count, I can be like, okay, this is my count, and on this basis, I can say this is the unique element. Okay, so basically, I need to store some mapping, some frequency, right? I need to store some frequency, like this element appears this much time, this element appears this much times, and the element that appears only 1 time is my answer, right? So basically, for this but data structure we use unordered map. Exactly. So we can do hashtag include unordered map, right? We can do this, and here I can do unordered map int of int frequency. So basically, here the first int will store which element it is, and second int will store how many times has it occurred, right? So what I can do is for I will just traverse this for int I equal to 0, I is less than size of the array, and I plus plus. Now I am traversing the array and I would be like, okay, frequency, increase the frequency of current element by 1. I mean, it can be written in code as frequency of current element. This is my current element, and increase it by 1, as simple as that. Right, yeah, as simple as that. You just need to increase the frequency of ARR is by array name, and you just need to increase its frequency by 1, as simple as that. Now, after this, we would get something like this in the map. So again, we need to traverse the map. We need to traverse the map like this and see if okay. So basically, in this part, what I have done is like I am traversing my unordered map. See, basically, each element of this map is kind of a pair, which stores 3 is the key and 1 is the value. So what to do is you can use structural bindings for auto element belongs to frequency. Like this element means this kind of block of 3 and 1. Okay, in which we say element of first is 3 and element of second is 1. So we can write it like this. If this is confusing, you can use your traditional loop. You can use this traditional loop also, or like you know, you can do is for you know, I mean, you can just do like this thing for auto key and value that belongs to my this, right? You will do it in this way also. I hope you guys got it right. As simple as that, if element of second that's equal to 1, return element of first, else you can return a minus 1. Yeah, that's all. Okay, so the thing is like there is some problem in this code. Okay, the thing is like logic wise, your code is correct, but you are consuming an extra space. O of n. O of n space is there. See, O of n space is there, and O of n time complexity is there. But this code can get better. For this, you will need to learn something called as bit manipulation. Okay, so basically, there is, in your college, you must have learned about the XOR gate. In XOR gate, what is this? Like, for example, if there are two same elements, one XOR one, that's equal to zero. That is, XOR of two same elements is always zero, right? And XOR of an element with zero is the element itself. These are the two properties that we need to learn. Okay, so how we can apply it here? Let's just think. Like, see, this was my array 1, 1, 2, 3. Right, I mean, sorry. 1, 1, 2, 3, and 2. This was my array. So what I can do is I can start with XOR equal to 0. Then I will do 0 XOR 1. That becomes 1. Then I do 1 XOR 1. So this one gets cancelled to this. Then I do this answer XOR 2, this XOR 3, and this XOR 2. This gets cancelled to this. At last, I would have 0 XOR 3. So that becomes 3. So that's our answer. So, and optimal, you just call it optimal, and you'll be like in PRR and in size. Okay, so what I can do is basically int exor that's equal to 0 for int element equal for I equal to 0, I is less than size, and I plus plus, right? So the thing is, you can do XOR equal to XOR of what? The current XOR and the ith element, and at the last, you know, here you can do return XOR. So that's it. I mean, that's it. Yeah. Uh, Unexpected, unqualified IDs. So XOR is basically, I guess, inbuilt. So with variable name, you can declare XO, and here also XO, and here also XO. So that's it. I mean, so this is our. So these are the both solutions for unique element, I guess.